we're going to start with a little interaction thing. So can everybody do this? Everybody, you in the blue shirt too. Very good. So everybody do this. That's very good. Can everybody do this? That is very good. That's very good. That's very good. So we're going to try a little movement now. So I'm going to show you a few pictures of IoT products. And I want you to tell me, by raising your hand, if you think it's true, if these products that I'm showing you the picture of and telling you a little bit about received 100% funding and it's an actual product you can buy. Everybody understand me? So if I talk to you about a product, you're going to raise your hand if you think it's a product that received 100% funding and is available to buy. All right. It means that it might have been something that somebody pitched, but nobody wanted to buy it. No, it's they never. It's these things that was pitched to like venture capitalists and things like that, and the venture capitalists actually decided to give them the money they asked for. Yes. No. It's you go to the market and was funded. So let's go. This is Ferngrove. It's an IoT device that you put on top of a wine bottle to detect if somebody has been tampering with it. It is supposed to be used for very high quality wines. The developer asked for $150,000. Raise your hand if you think that this product was fully funded and is possible to buy. About 30%. Thank you. All right. So this is... Shut up. All right, let's continue. So this is the smart cat bowl. This allows a cat owner to see the optimal amount of water that your cat is drinking to make sure that your cat stays hydrated throughout the day. The developer asked for $50,000. Please raise your hand if you believe that this is a product that received funding and is available to purchase today. I'd say 60%. That's very good. This is Beat Twitter. This is a ring that you wear, then if your heart stops beating, it's connected to your Twitter account and sends a eulogy to all your followers. Thank you, dear followers. Unfortunately, I have left this brutal world. You were lovely. Goodbye. Something like that. So, how many people, they asked for quite a lot of money, I think, but I don't remember it. So how many people believe that this is a funded product that is available to buy? Seriously? All right, so like that, how many people believe that this is a funded product that is available to buy? Hands up, everybody. All right, about 50%, very good. Okay, last one. This is OmniBottle, the smart water bottle. This water bottle allows you to, with your phone, connect to it. This is, by the way, a transparent water bottle. And it allows you over Bluetooth to connect to it with your phone and see how much water is in your transparent water bottle. The developer asked for $150,000. Please raise your hand if you think that they got the money and it's available to buy. 50%, very good. All of the products that I've shown you today, except this ring, have been 100% funded and is available to buy today. I would not recommend buying this, though. So, I am not here to talk to you about stupid ideas. Because apparently, a really dumb idea can get you $150,000. So in that definition, is it really a dumb idea? No, it isn't. It's a great idea. Now, I'm here to talk to you about really, really, really poor implementations of relatively good ideas and how you and your company can avoid doing these really, really poor implementations of good ideas. You see, I am an IoT developer. I spend a large portion of my days writing code for microprocessors and controllers and doing things that actually interface physical objects with the digital space. That's my job. And I do a lot of kind of cool stuff, but Sorry about that. So, but the thing is that as soon as I find something really cool, like I work with this client, oh, this is so cool, I want to tell everybody in Ukraine about this awesome, cool product we're working on. They do this with me, and I get a full load of paper on me, and they say, this is an NDA. Please sign it that you can never say or breathe about this product in a room with anybody else, or you cannot work on this project. All right, so what can I tell you? Nothing. So I thought that in 2015 in September, it was the happiest day of my life. It was an amazing day, because I both got to move in with the woman of my dreams in a house of my dreams. This is my own house, an amazing house. It's very nice. Come to Sweden. We have IKEA. And I thought, this is amazing. We're going to do so much cool things here. I'm going to build IoT devices in my house based on the principles that I use at work, and I can go with them and talk about it to conferences. This is amazing. It turns out, though, that when you buy a house, apparently you need to mow the grass and do a lot of things that takes a very long time, which means you don't actually have that much time in your spare time to build IoT devices. But I thought, no worries. I'll just buy IoT devices, and I'll make a talk how you can actually integrate different IoT devices with each other. I was here last year, if anybody remember, talking about how to reverse engineer wireless devices and stuff like that, right? So, this talk came to me 3 days in, trying to get one of these devices to actually connect to my Wi-Fi. This is the internet of less useless things, what you should think about when you design and sell products. But the most important part of an IoT product is the people around you. People around you are going to help you solve your problems. But first, let's do another exercise. What does Santa Claus, an IoT expert, and the Easter Bunny have in common? Exactly, they do not exist. Very good. Give the man a round of applause, everybody. There are no such things as IoT experts. I am not an IoT expert. I am a hardware development expert on software protocols and radio transfers. That is probably as far I would like to go to say that I'm actually relatively knowledgeable. But I work in a team with people that do a lot of these things, and together we form an IoT expert team. And you are never going to be an expert in IoT. You're never probably going to be an expert in any of these things. It's about as sane as saying, I'm an expert in everything from databases to HTML5 and everything in between. I know everything. But it's impossible. It's impossible to know everything. So these people, because you've seen them, I promise you've seen them. If you go to LinkedIn, how many people have seen people that claim they are IoT experts? Nobody? Yeah, quite a few, right. And they're not lying. I mean, because they mean that they're an expert in their team. But we have to make this very, very clear to us. When we talk to our bosses, when we talk to our team, when we talk to our team members, we need to have a team of very, very different skills to build good IoT stuff. If we need to have a machine learning component, a hardware guy should not learn to do machine learning. We should get a machine learning guy to do the machine learning things. Likewise, a machine learning guy should not learn how to do hardware things. A hardware guy should do the hardware things. And you need to have this very clear new concept, because otherwise, you're going to get things that I'm going to show you in a little minute where people really, 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 really got it wrong. Also, your most important asset is your users. We're going to talk a lot about users, but users is super important to you. So bring them in early. Keep focus groups. Do all of these things. I'm going to show you a few design guidelines now. But if you refuse to show your product to your users early on in advance, how many people ever bought an early access game? Quite a few. That's very good. I know you did. That's who I was going for. So, early access game is basically, dear user, would you like to pay to be my beta tester? Normally, I'd pay a testing expert like these people, but since you're ready to pay to be my beta tester, would you like to do it for me? Very nice of you. That is paid access. And you can do the same with IoT stuff. You can sell somebody, okay, this is a very cheap product. You can go like on Kickstarter. This is a prototype. Would you like to buy our prototype? And people will say, yes. Yes, I would like to buy your prototype. That's an excellent way of giving your users something that they actually want to interact with, but also getting their feedback and getting information from them. But when we are designing things for users, we really need to think about this concept. So a lot of developers are female now, so they're actually married to guys who also seem to have a problem with bulky things with cables. So we have renamed it to the marriage interference factor. But then we realized that, well, actually some people aren't married, but just living with people. So let's say the spouse acceptance factor then. It all means the same things. It's what you can get away with. When you build things that has cables and lots of these things, it's impossible for you to sell them unless you think that your customer can bring it home to their husband or wife and actually say, look what I bought, it will do this, isn't that amazing? And they will not directly say, you do not bring that ugly thing into my house. Then you have a problem trying to actually sell it to your customer because they're going to bring it back. Because no matter how good your product is, it is not worth a divorce. Those things are expensive. Let's do a little bit of a test. So raise your hand if you think any of the following pictures have a high marriage interference factor. Oops, there. Does this picture have a high marriage interference factor? I love that. All right, does this picture have a high marriage interference factor? A few think so. I'd say this is probably okay. It's be okay in my home. She will be happy with this. Let's go with this one. Does this have a high marriage interference factor? Very good, very good. All right, and the last picture. Does this have a high marriage interference factor? No, that's very good. True. It does not have a very high marriage. This will be perfectly fine with people. Why do you care about this? So my spouse is my critic in life. I love her to death. And she is my most interested and motivated product owner. When I'm working on a project, I always make sure that she is included in my NDA so that I can actually show her what we're doing and actually get her feedback. And your spouse or your partner can be absolutely most interested and motivated product owner you have ever met. Trust me. I'm going to give you a small example. Many, many years ago, I worked with a company who was going to reinvent the fridge. Build a smart fridge. Swedish company. And they wanted everything to have a scale in the bottom of the fridge. So you can tell exactly how many grams of milk, butter, cheese, you name it, they would have it. It's actually quite smart design. You would scan the barcode of the product, you put it on any scale, and it would register, okay, this is milk, this is cheese, this is everything. And I pitched this idea to my wife, and she went over to the fridge, opened it up, and said, yeah, that's a great idea. And then she said, because a fridge is a stackable storage space. You stack your butter on your milk. You put your cheese on top of your butter. Right? We all do that. We sat a whole room of CEOs, venture capitalists, developers. Nobody even thought about it. We would probably have built this product. But we showed it to a user. And a user gave us feedback that, dude, you're not a very clever person. So that's a really helpful thing. No matter if it's your spouse or if your users, cherish them because they are the people that will give you money. And that's actually our end goal in most time of life, all right? So, continuing on the user subject, let's talk about design and user experiences. I like this. This is my home router. But when I started looking at routers to have with my IoT network, there were so many routers. And most of them look like this. I was like, why would I want this in my home? How would I mean, like, it looks like a death trap from Doom. Yes, it has spikes, and it's red, and it's black, and it's quite possibly a spaceship in disguise. I mean, yeah, probably, but I mean, it's like it's just not it's not practical. And I know so much about antenna design and everything, and I know that this in theoretically could be more effective than this, but it doesn't change the fact that this in my home is actually much, much more effective than this. So apparently they didn't care about the fact that this actually could have been very useful. And this does not have a high marriage interference factor. Trust me, this is bad stuff. Design it to be anonymous. Do not make it flamboyant if you don't have to. Like, if you're not designing it to be the rooster of the routers, you do not have to do that. Make it something we can put somewhere and it won't be seen. And people will be much, much more happy with you. This is a good thing. This will make it much easier to bring it into your house as well. The second thing we need to talk about is being honest and having respect for our users. So when I started doing this, I bought a lot of stuff. I bought a whole box of things. I wanted to build IoT things. So I went on the internet and I bought all the things. And one of the things that I really, really wanted was this system to measure my electricity, like how much electricity am I actually consuming. So I bought this thing that you put on top of the meter that you have in your home, and it gave me really nice data. And after a few months, I went out and like, okay, now I have these other things that I would like to correlate with this data. I'd like to know, for example, is there a difference between when I'm home and when I'm not home, how much data I'm getting by the hour, because the things wasn't that exact. So I talked to the company that sold me this, like, hi, I'd like to get a hold of your API to get your data. And they told me, no. You can have our wonderful report in our app that, by the way, cannot be exported unless you take a screenshot. So I scrapped that idea. I built my own, and now I have these wonderful graphs that very clearly show me that as soon as I get up in the morning, until I leave for work, and when I get home and start my TV or Xbox or whatever I start when I get home, I have very, very clear power consumptions, which also means that over every day, I can see that if I forget to turn off a lamp, I have a higher amount of power. But if you do not offer this to your users, we are going to stop using your products. If you're a product and somebody really, really wants to use this, if you want to do an IoT product, a product that actually enables them to be powerful in their environment, you're going to allow them to have the data. And I know this is a problem, but you have to respect the user. You have to give them the tools to build actual IoT. Because you know that the data is the new oil, right? You know that? You heard it before? Data is new oil. Data is what worth money. That's why Facebook is free, because we're the product, right? We all heard that. The same thing goes with IoT. We're going to be worth so much money when you have your health bracelet on, and Facebook and Google can show you a product and see that I showed you this product and your heart rate went up. That's a lot better than I showed you this product. Who cares? We can tell you that your heart rate went up when I showed you this lovely new MacBook, and you went, ooh, I want that. I mean, it could have been other reasons that your heart rate went up, like that you were actually watching your phone while running on a treadmill or something, but you know, it's a work in progress. But what if your treadmill is also connected to things? We could know that you're actually running on your treadmill and adjust for that. But we want this data, and we're going to use this data. But we also have to give it to our users, so our users can actually do real Internet of Things stuff. So, what does the American NSA agency, National Security Agency, have in common with the sex toy WeVibe? Any guessers? That is true, but that's not the thing I was going for. Anything else? It spies on you. Very good. One is a little bit more invasive than the other one, though. Yeah, so let's talk about this. If anybody owns this one, this might be a good time to listen. I saw somebody laughing. Do you own one? No, sorry. All right, so what happens with the WeVibe? The WeVibe is a mobile phone connected sex toy. Nothing to be ashamed of, sir. You can laugh. And every time you use it, it sends communication to the device over Bluetooth. But what it doesn't tell you, even if you read the end user license agreement, is that it records what setting you're using, how long time you used it, and some versions of the app where you use it, as in GPS locations. And it sends it to the cloud. It sends it to the developers of these things. So if you own a WeVibe and you use it frequently, the developers of that product knows exactly how often you are using it and where you're using it, which is quite strange. So it's almost like the NSA, who knows this without you actually giving them money for it. So we have to be open and we have to be honest with people, because building trust, building genuine IoT network will require trust. People must trust us. If they don't trust us, we have no chance of ever having an IoT network that will do anything good, because everybody will just keep everything locked in behind so many things, like, no, you're not allowed to access my data. We have to give users the choice to deliver data to us that we want to show them. All right, so this is the Revolve. This is another type of breach of trust. They did not share their data. What did they do? Anybody know what Revolve did? So Revolve cost $300, which I've been informed is a relatively nice apartment here in Lviv for a month, correctly? Yeah, it's a very nice apartment. It cost $300 to buy this thing. And you could have it for 2 years, and then they decided to, no, we're not making any money on this, so they shut down their servers, which stopped it from working, because it required to be connected to the internet to their servers. So you paid $300 for something, used it for 2 years, and then, no, by the way, you know what? It's gone. And we have to build systems that does not require us to be in business, because that means that people will remember you. And the next time if you were a designer on the Revolve team, maybe even the CEO, and you go up and do a new thing, trust me, when the magazines are going to remember that you were part of that team. So we have to be honest with our customers. I mean, that would be like selling a mobile phone and charging somebody to build apps for it, right? And who would do that? Apple. So don't give your customers the short end of the stick. It's not nice. It's not something we're supposed to be doing. All right, so let's actually get into something that I get to do during my daily basis. The hardware platforms. How many have ever seen one of these? Did you see it in school? Yeah. All right, you did not see it in school. Do you see it in work? Very, very good. This is probably something that you will be working for. Maybe not the ATX Mega or something like that, but for most hardware platforms, this is what you're going to end up with. Because if you look at the Arduino and all that stuff that you have, these are far too expensive to be put in a production product. An Arduino is compared to this one, you can get like 1,000 of these for the price of one Arduino. And it's the same processor that sits on the Arduino. So you probably if you want to be a hardware developer for instance things, you probably want to learn a little bit about this. You want to understand a little bit about this. But that's show off that we have this amazing idea, then don't even bother with this stuff. Grab something like this, off a shelf, costs nothing, buy it from China, build your prototype, prove that it works, get funding, hire me, and I'll help you do this. Deal? Great. Because you do not need to know hardware to do this. Most things of these have examples, and I don't care what other people tell you. They're good enough to do a prototype. They're good enough to do a prototype. A 3D printer and a prototype and an account on AliExpress or something, or eBay, is enough to build and an internet connections to find guides. It's enough to build most prototypes. And if you know a little bit of software development, you can go a really long way in this business because it's actually quite simple stuff. We'll help you when you get there you want to be. That's not something you have to do. If you have an inspiring idea, if you figure out the product of tomorrow, don't let 6 months or 1 year of knowledge be in your way. Just build a prototype, find someone to build a prototype, worry about the hardware later. There are no perfect hardware platforms. But there are perfect battery-powered platforms. So let's talk about battery-powered devices that does not suck. How many people here own a battery-powered device? I see 30% of the people that doesn't have a cell phone. That's very impressive, guys and girls. So how many people have had an iPhone that ran out of power in 12 hours because you just were doing a few phone calls, using a few apps? A few people, yeah? How many have had an iPhone that actually lasted longer than 24 hours? One person. It was which? Very good. So, if you actually just think about these things, this is an example of an Arduino Uno and an Arduino Pro Mini. Sorry. If you modify them to actually work with these things, and you actually think about it, let's give you an example. If you take the regular Arduino, the regular processor and everything, and you put a 9-volt battery on it, it will last less than a day. But if you take the Pro Mini, put a 9-volt battery and do nothing, it will last for 10 days because it's a smaller device. But if you think about it, and you remove the power LED, and you change the regulator to a regulator that doesn't cost you like 1 cent, mine is up to 3 years. The math says it's supposed to do 3.5 years, and it's still going strong on a 9-volt battery. That's different. But there's one more thing to this than just doing that. And that's something called sleep timers. So if you have a notebook, write that down. If you're going to do hardware development, think about sleep timers, sleep interrupts. This is basically the thing that you can tell a microprocessor to, yep, you're done now, sleep for 2 hours, then go back up and get me the temperature, report it to that service, and then go back to sleep. Mush! We'll be happy with that. The thing is, though, that, I mean, honestly, do you really need to know the temperature of your bedroom with 1 second intervals? It depends, that is true. Could you give me a use case for when you would actually like to know that? Well, absolutely. There are use cases where you want 100% power, but let's say for light switches, you already have power because you have power to the lamps. It's a different use case. But for temperature sensors and things that you actually put, very, very seldom can you not get away with using interrupt-driven development. It's a good thing to think about. One more thing to think about when we're actually doing hardware development is what sort of protocol we're actually going to use. So when I bought these things, you remember the big box I bought because I want to build so many cool IoT devices, right? So they had Philips Hue, a smart lamp. Love that. But I'm going to get back to Philips Hue. They also had some power connectors and stuff that communicated over HTTP and was battery driven. And I'm going to tell you what that is a bad idea. So this is a regular kind of view of the sizes of the protocols, the data sizes. I call it the mustache equivalent. So the AMQP is still pretty small, but it's a defined mustache. MQTT is very small. It's like a little tango rebate. Stomp is a real sheriff, so American movie sheriff mustache. Let me introduce you to HTTP. HTTP is more, despite being a lot faster to actually connect to all these services, it is always a lot slower. Sending huge amount of data over HTTP is not a good idea. It's just not a good idea. Please go in and read about these MQTT, the message queue telemetry protocols, if you wanted to build one of these products. You don't have to photo. We're going to put it online if you want to, sir. Don't worry about it. But we're going to put this, like if you do this with MQTT or AMQP, they're so much faster. They give you so much more than HTTP does. Like they give you quality of service things. They give you back and forth communication. They give you so much things that in pub-sub patterns that you don't have with HTTP, with less data than one HTTP call. Doing 1,700 HTTP updates is equal to 20,000 MQTT package of the same data. That also means that using these means we need less power. The smaller the protocol, the less time we're actually awake, and the faster we can go back to sleep. So we will use less power. The same thing goes with HTTP requires some sort of Wi-Fi communication. If we don't use Wi-Fi, we can't use HTTP. So we need to use radio acceptance protocols. MQTT is much more simpler to implement over radio protocols and stuff like that. It's even available today to just get from most microprocessors, which will give you less of a footprint on your battery power, right? And a small CPU, like 8 megahertz, it's not ideal to do like string concatenations and stuff like that to just build up a HTTP request. It's much better to actually use built-in functions and stuff like that. All right? So, design with failure in mind. Now I'm going to annoy the cameraman a little bit. What do I mean by that? You have to assume that things fail. Thank you, sir. You have to assume that things fail. Things can go wrong. These guys are clearly assuming that things might go wrong because they're using 2 forklifts. Let's say that we want to control a lamp with a microprocessor. If we do a connection like this, and the microprocessor actually breaks, we will have to look for the error or the problem in the dock, right? Because there's no way for us to turn on the lamp. But if we actually reconnect it so that the lamp gives us a signal, that the button gives us a signal that, hey, the lamp is on, I turn on the lamp, and the microprocessor, okay, I'll report it to the services. Right, the lamp is on, it's up, it's running. Now, if something just breaks down here, we don't have to care about that. We could even add electronics to the actual device to see, is there light in the room? Is the lamp actually working? And we can start sending fail reports. If we have a product in a large house like this one, we could have cheap sensors in each one of these, and they could send information to service teams. Hey, lamp A, B, and D is broken. Go and fix them. And you would never even have to do that because it will become fully automatic. But we have to design things with failure in mind. Let's talk about cloud services with failures in mind. You know, things happen. Normally, most IoT products that I bought had this setup. They were connected via the Wi-Fi to a cloud service. So if my Wi-Fi router died, they stopped functioning entirely. It was impossible to communicate with them. 99% of all the things that I got, all the things that I've looked at, has this design approach. So how do we solve that? Well, the third thing we can do is actually make them run without the internet, like log data. Put an SD card or something there so we can keep the data. But a much better solution would be, let's put an actual field gateway there. A Raspberry Pi or something like that that they can communicate to, that be hooked up to your Wi-Fi and power your services. So that your services can both be reached from the internet, but also from your internal network. So if you're home, you want to turn on your light, that's still possible. Because trust me, if you build this system for your spouse, and your spouse is not a geek like you, they will not accept not being able to turn on the lamp. But this system also has flaws. If we're going to design with the failure in mind, now we're starting to talk about what type of system are we actually designing? What are we building? Maybe we need dual internet connection. We can use Ethernet and Wi-Fi. Okay, so it's one less thing that can actually break and we can lose it. But we can still lose the field gateway. So we can build up 2 field gateways with even more failovers if it's a very important system. Now, we can go as far as we want with this. We could split up to Amazon Cloud and Azure Cloud, where we could have the Azure IoT Hub as our backup system, or as a primary system, but we could have like an AVS queue system as a backup, and they could just synchronize data between them. It just depends on how important the system are and that it keeps working, right? But you have to think, you have to design with failure in mind. Oops. So, I assume that a few of you can actually read the fault message, the error message. But let's say this was an actual problem. I have this presentation on another computer. And why do I have this presentation on another computer? Because very good, I designed with failure in mind. And that's really important. So let's talk a bit about placement. We looked before at this amazing little thing that looked, the router, very, very good router. Things that we can place out of sight is out of mind. Like people don't see what they're accustomed to. How many people can tell me, without looking up, without looking up, how many fire extinguishers do we have in this room? Without looking up. You have no idea. Because you don't see it. You don't look at that. They're just there in the roof. So if you can build a product that looks like something that we are accustomed to have in our homes, people won't see it. It's like a psychological block. It just disappears. It's like a cloak of invisibility. It's amazing. Amazing how it works. Let me give you another example of that. Look under any table at any school, and I promise you will find gum. Why do you find gum there? Do they not clean? Yes, but don't look. It's underneath something. And people look underneath things. It's just gone. Trust me. I guarantee you there is gum under 50% of these chairs. All right. So putting something inside a wall can be tempting. When I was doing my IoT things for home, I was like, okay, I'm renovating this wall. I could put this thing inside and it'll be gone. But that is a really dumb idea. I'm sorry? Maintaining. It's impossible to maintain it. It's just going to be there forever. And I mean, you need to put power. And what happens if it actually is something wrong with it? What happens if it has the same functions as a Nexus 7, which, randomly explodes? Or randomly, I don't know. Maybe it's a function in the new Android version. We don't like this user. All right, but there are walls. There are things that you can put that will actually let you access them, like these wall lockers and stuff like that. You can still put them in the walls, you can still pull all the lines, but if you put stuff like this, you can actually get to them. And people don't even see them if you put them in good places. People won't see them, people won't think about them. They are common practice, therefore they are invisible. Now, a lot of us in this room are software developers, quality assurance people, or UX designers. And I come from a long line of hardware developers. My father was a hardware developer for him. And we have an issue. We don't believe that you guys know shit. Which is bad. Because many years ago, when I went into actually doing more than just hardware, I realized that you guys have a lot of tricks up your sleeves. So let me talk to you about a few of those tricks. And I want to do that with field gateways. Field gateways gives us offline support. But that is a problem that app developers have been struggling with since the first iPhone. How do we give offline support to our apps? How do we solve these things? Today, we're working on offline support for web apps. And we're actually making it possible. And these are important things, these important steps. Likewise, when you log into a service, you're not afraid to use your Twitter handle to log in. You're perfectly happy to let Facebook handle your login and communication with this site that you're actually logging into, right? This is common practice in your world. But in my world, where I come from, when you sell to people, maybe we can help people by collaborating, because you do not want to have 50 field gateways. If you buy a product from me, sir, and you have put a field gateway, that's fine, right? 1. How about 2? For the next thing, like you have 1 for your lamps and you have 1 for my device. That's a temperature sensor. How about 3? How about 4? How about 97? I mean, at some point, when you're going to have like a server room of field gateways, we're going to have a problem. Which means that we are going to have to talk to each other. We're going to figure out like a platform standard for field gateways. Personally, I've been looking a lot at blockchains. What if we could build field gateways that are blockchain enabled so we can clearly identify which device things came from, but we could use each other's things, like we can choose each other's hardware devices, so we didn't have to have 50 field gateways in our homes. They're pretty good. I mean, 1 field gateway to connect all your stuff and make them IoT enabled. Apple and Open Hub are 2 of my favorites for this. They're doing great work with this. Apple released their solution now for the new phone. It's pushed to all of the new iPhones with the latest version. Works really well and actually has an open source implementation. So you can build your own on a Raspberry Pi if you want to build a product that implements this. You can also do this with Open Hub, which is a 100% open source project that works on Raspberry Pi in Java. So there are 2 very, very good tools that builds field gateways, that lets you connect to existing things and things that you build yourself. So it's a very, very simple thing to do all of these items. But you also have agile development. You guys do agile development. Software people don't think about that, or hardware people don't think about that. This is a common way to look at a hardware system. How it's built. Well, it's a device that talks to our service. That's how we always did it. That's how my father did it, and the father before that. And then they go into a rant about C and pointers. And if you look at actual agile development, we talk about building a really small thing and then being able to add to it. How do you add to this? Let's say, okay, we support AMQP and HTTP. But now I want to communicate with MQTT because I think that's better, or my product supports that. It's not going to be possible because we cannot go into this monolith of code and add all these features. It's not going to be possible to do that. So if we start thinking like an actual software developer who builds APIs and things, we could have something like this. We can have like an Azure IoT queue system where we can take 100,000 of requests a minute. We can build adapters that communicate with this one over AMQP and just have 1 protocol. But we can do MQTT, we can do HTTP, we can add our own, we can write perfectly fine things that we want to use ourselves and just keep adding to it. Just do pub sub. And when it's the same thing, we can have consumers. If we want to try something out, we just add a consumer. If we want to take something out, we just remove a consumer. Think about it. When I called up that, you remember the company that didn't want to give me my data? I would like to have my data. I'm ready to bet you a lot of money that this is their solution. They did not have a simple way to add me a service where I could get my data. But if they had an architecture, something like this, they could very, very easily go in and say, you know what? I'm going to add this for you. I'm going to add this up for you. That makes sense to everybody? It's very good. All right. So the second thing that these people learned is that administration is a devil. You guys know this with continuous integration and everything. And that's something that we never do. But with this solution, we can actually do continuous integration because we can remove a consumer, we can add a consumer, we can add a consumer and do A/B testing. We can have 0 downtime but still develop and deploy to production. This is something that we really need to think about. All right, so we're going to recap a little bit before we go into questions, okay? Everybody's awake? Great, awesome. So, always design for WAF, or wife appreciation factor, or marriage interference factor. It will be the better system. Anything your customers can bring home and not be kicked out because they brought it home is a good product. Keep it hidden, but accessible. So this goes for the same things as, the WeVibe. Select the device most suitable for the job, but do not prematurely optimize. Like if you want to do a prototype, use a prototyping platform. Do a hardware platform. Do an Arduino or something like that. If you're ready to go into production, you have your money. You're just going to build 1 million of them and become a millionaire and sell it and move to Hollywood. Fine, let's talk. Let's find something cheaper. Design everything with failure in mind. Things break. Make sure that things actually work after that they're broken down. And things that can't be replaced will be there forever. You will never get rid of them. And just as with most software systems, the end goal is scalability and adaptability. All right. IoT is not as a product connected to the internet. A lot of people talk to me about this. It's like, it's just hardware connected to the internet, and it's not. It's representing a physical object on the internet. I don't care how you do it. But if you think about these things that I talked about right now, you're going to have a software system that I'm not going to be annoyed at, and I think a lot of people with me will not be annoyed at it, and that will help you make a great sale. A friend of mine, he built a mirror, a magic mirror, and his wife has a little gallery. So this was his prototype. Built this magic mirror. Has everybody seen this? You put a screen behind a mirror, and it shows the image if you put it in white and black. It's actually quite nice. He showed this to his wife, and he just made them do a quote. If you have dreams, it's your responsibility to make them happen. And he made them go every other day. They change to something else. Some really lame quote. He got $1,000 each for them after he did a little bit of a nicer presentation around the edges. Nothing else. There's going to be really big product thing here. We're going to do a lot of cool things with IoT, but we also have to think about what we deliver. Simple solution can be an amazing product, but an amazing product has to be possible for the user to keep coming back to and not be annoyed and frustrated when they have to use it. All right, we're going to open up for questions in a moment. My name was Karl-Henrik Nilsson. I did the presentation. I work as a knowledge consultant for 1337. So when you have this amazing product, come talk to me. I'll help you. Very good. Thanks for listening.